This talk is sponsored by Decentology. Decentology is the innovative company behind the Hyperverse, the open, composable smart contracts marketplace that makes it easy for developers to build Web3 apps without writing a single line of smart contract code. Learn more at decentology.com.
Hey there, welcome to Stacks 101, Building Dapps on Bitcoin. In this talk, I'm going to go over what Stacks actually is, give you a quick rundown of how it works, why you might want to build on it as a Web3 developer, and then we'll go look at a little bit of sample code. We'll look at Clarity, the native smart contract language that Stacks runs on. And then finally, since we're a little bit limited on time and I won't be able to do an actual full-on code demo, I have a link to a resource page that I put together in case you are interested in looking a little bit more into Stacks, maybe start building some stuff on it. So, real quick bio, we'll do this really fast. I don't want to spend too much time on this. My name's Kenny. I'm the developer advocate at the Stacks Foundation. I've been a full stack dev for about 8 years. About a year and a half ago, started getting really into blockchain, Web3, started building things on Ethereum and Solidity, and then I found Stacks and fell in love with it, and I'm going to go over some of the reasons why I did and why you might also be interested in building on it in this talk. So let's go ahead and get started by going over what Stacks actually is. So at a high level, what Stacks does is it allows us to build smart contracts for Bitcoin. And what that means is that a lot of the functionality that was previously unique to just Ethereum or maybe networks like Solana, we can now utilize with Bitcoin without actually changing Bitcoin itself. And that part is key. So Stacks is connected to Bitcoin with a consensus mechanism called proof of transfer. We'll go over this a little bit in more detail in a minute. And what it's kind of being branded as is a layer 1.5 blockchain. So Stacks is technically its own blockchain, but with this proof of transfer consensus mechanism, it cannot exist without Bitcoin. So that's kind of where the layer 1.5 comes in. In order for something to be a true L2, it can only perform the same functionalities that the L1 can. So like with Ethereum, the smart contract functionality, the fully expressive smart contracts and the programmability, they're built right into the layer 1, into Ethereum itself. And so L2s like Polygon, they can then take that same functionality and make it more scalable. Stacks is a little bit different than that. So the goal of Stacks is not to just take the same functionality that Bitcoin already has and duplicate it, or not duplicate it, but make it more scalable. That's more similar to what something like Lightning might do. With something like Lightning, you don't actually have any extra capability outside of what Bitcoin can already do. It just takes that same capabilities and makes it a little bit faster and more scalable. The goal with Stacks is to actually extend Bitcoin's capabilities and add capabilities to it. And so that's kind of where this 1.5 comes in. Something else I want to point out really quick, because this is often a point of confusion, is that Stacks is an open network. So anybody can run a Stacks node and verify the history of the chain just like they can with Bitcoin. It's not a federated chain. It's completely open and decentralized. A federated chain would be something like Liquid. And what a federated chain, the compromise there is it's not an open network, but that allows you to run a much faster network because the transactions are validated and managed by this closed network of people. But the downside there, obviously, is that it's not open and completely decentralized. So Stacks is open. It is a decentralized network. One thing I also want to mention really quick, because this is something that people often get stuck on, is you'll hear this language if you're in the Stacks world for any amount of time of built on Bitcoin. That can be a little bit misleading because it's not technically true. Stacks is, I would say, built for Bitcoin or built with Bitcoin, and it does leverage some of the security of the Bitcoin network, but it does not inherit all of its security. So this is a common misconception, is that Stacks is as secure as Bitcoin, and it is as hard to hack or fork or compromise Stacks as it is Bitcoin. That's not quite true. Because Stacks is its own separate blockchain, you could compromise Stacks without necessarily compromising Bitcoin. However, what it does mean is that because Stacks is connected to Bitcoin via this proof of transfer mechanism, and because it cannot exist without Bitcoin, that means that the entire history of Stacks, including any forks, have to be recorded onto the Bitcoin blockchain. So what we're really doing with Stacks is we are using Bitcoin as this broadcast medium. So every transaction that happens on Stacks has to be broadcast via Bitcoin. So while technically you could compromise the Stacks network without necessarily compromising the Bitcoin network, what you would have to do in this case scenario is you would have to broadcast that attack publicly on the Bitcoin network, which means that it only requires one honest Stacks miner to cut that attack off. And so that's what people mean when they say that Stacks inherits Bitcoin security or that it's built on Bitcoin. Just be careful that you don't take that too literally and think that Stacks is literally built on Bitcoin or in the same network as Bitcoin. It is technically its own separate blockchain, but it cannot exist without this proof of transfer consensus mechanism. And that's what we're going to go over a little bit more right now. Or excuse me, after we go over this, why build on Stacks? So we got into this stuff a little bit on the previous slide, but Stacks is built with Bitcoin, which means it extends Bitcoin's functionality and it uses Bitcoin as the settlement layer. So one really cool aspect of this is that Stacks actually has visibility into the Bitcoin state. And so what we can do here, and we're still in the early stages of this, but we're seeing more and more applications built utilizing this methodology and technology. But what we can do is we can actually enable dApps that use Bitcoin as currency. So because Stacks has visibility into the Bitcoin state, we can read that Bitcoin state and initiate transactions on Stacks based on what is happening on the Bitcoin chain. And so eventually what we'll be able to do is we'll be able to use Stacks as sort of an invisible programmable smart contract layer, but users may only ever have to interact with it using Bitcoin. So what they may do is they may initiate a Bitcoin transaction, which will then trigger a Stacks transaction, which will do some sort of logic on the smart contract using Clarity, the language we're about to go over, on the Stacks network. Behind the scenes, it will convert the Bitcoin to Stacks in order to use the gas token to actually run and fund the transactions just like we would on any other blockchain. And then on the other side of that, behind the scenes, it would complete the transaction, convert whatever action happened back to Bitcoin, and transfer it to the other person's wallet. So the goal here is that this really unlocks a ton of functionality for Bitcoin. Previously, Bitcoin was often seen as just a store of value, and so you couldn't do things that you could do on Ethereum with it. But now with Stacks, you are able to do those things. So one of the other things I want to talk about real quick is why. Why would we want to do that? Why would we want to separate those two things? So if you're trying to make a blockchain or a decentralized network sound money or a programmable system to build censor-resistant software on top of, those actually end up being two relatively different use cases. And so you want the blockchain to have certain qualities based on one of those two use cases. Ethereum can run into problems when it's trying to be both, and we hear debates about this all the time. Is Bitcoin sound money? Is Ethereum sound money? But the bottom line is that they're both successful, they both exist. Previously, it was only possible to build programmable things on Ethereum, so if you did prefer Bitcoin's consensus mechanism of proof of work, and if you did think that Bitcoin was a more secure, immutable blockchain, you still could not use that to then build censorship-resistant software on top of, or smart contracts on top of, so you had to do it on Ethereum regardless. Now, if you are of the mind, like I am, that proof of work is a more secure and immutable consensus mechanism, you still have the ability to now build programmable smart contracts and dApps, utilizing Bitcoin as that final settlement layer. And so that's the sort of high level of why you might want to build on Stacks. And then again, that is made possible with this proof of transfer consensus mechanism. We'll go over that in just a second, but I do encourage you, if you're interested in it, some of the resources I have at the end really go deeper into that. It can be a little bit difficult to wrap your head around at first, but once it clicks, then you'll kind of realize how powerful it is, because it does allow us to connect into a more secure blockchain without actually having to change it at all, and inherit quite a bit of its security capabilities. And then finally, one of my favorite parts about Stacks is that they have the Clarity smart contract language. So Clarity is a language that was created specifically for Stacks. It took a lot of the common exploits and flaws that Solidity has, and it sort of built a smart contract language that was purpose-built to avoid some of those common flaws and exploits. So Clarity is designed to make it much easier to write safer code by default. And after we cover proof of transfer a little bit, then we'll switch modes and go and spend the rest of the time talking about this Clarity smart contract language. I'll give you the kind of the high level overview of what makes it unique, why you might want to build on it, and then we'll look at a really brief small code sample, and then you'll have some resources to go dig into it further if you would like. So This diagram kind of explains at a high level what is happening in proof of transfer and how stacks actually functions and how the consensus mechanism works. So it starts with the miner, and that top left is the first step. So the way I like to think about stacks is recycling the energy of Bitcoin, which is also something that's really cool because a big concern with Bitcoin is that it has too much of an impact on the environment, whereas a blockchain that might use proof of stake uses less electricity. I'm not going to get into the proof of work versus proof of stake debate. That's a whole separate can of worms on its own. But the point that I want to make here is that Bitcoin does use a lot of energy. There's not really any way around that. People can debate the pros and cons of that and whether it's worth it. But what Stacks does is it allows us to actually recycle that energy. So at the bottom layer, you have Bitcoin, where you are exchanging a resource, in Bitcoin's case, energy. You're exchanging energy for Bitcoin. That's the proof of work. The proof of work that you're doing is you did this computation of this cryptography task. You spent the energy to complete the problem. You're rewarded with Bitcoin. Then, next level up, we have Stacks and the proof of transfer consensus mechanism. So a miner mines Bitcoin, they have the Bitcoin, and then what they will do is they will then spend Bitcoin in order to mine Stacks. So it's sort of one level up from Bitcoin. So this first step is the miner will spend Bitcoin, and then there's a verifiable random function that is weighted based on how much Bitcoin you actually spend, and that is what determines who wins the block and gets to mine it. And then what will happen is that miner, excuse me, Stacks will take the Bitcoin that was put up as that the miner put up, and they'll transfer it over to stackers. And what stackers will do is they will lock their stacks into the network in order to boost its security, and they're rewarded with a large portion of the Bitcoin that the miner has put into the network. And so there's another consensus mechanism called proof of burn, which is similar, except that in that case, the cryptocurrency that you're using as the base layer is just burned and it's gone. In this case, the Bitcoin is transferred to other members of the ecosystem, in this particular case, stackers. So then that miner, after the Bitcoin transfer that they put up is done, they will then write that transaction to the Stacks blockchain and then receive the a portion of the newly minted Stacks reward, and then the transaction fees, and then the process starts all over again. So again, I have some resources at the end to dive more into how this actually works, because it can be a bit confusing to wrap your head around, but that's how it works at the high level. Let's quickly dive into Clarity with the last few minutes that we have, so I can go over some of the reasons why Clarity is unique and why you might want to write with it. So first big difference between Clarity and something like Solidity is that Clarity is interpreted and not compiled. So when you write a Clarity contract and then you submit it to the chain, it's getting submitted exactly as it was written. So it's not compiled to bytecode. So this has a couple of advantages. One, it just eliminates one more process that can go wrong. It's unlikely, but it's possible that there's a bug in the compiler. It's just another intermediary step that in Stacks is not necessary. And then the other major advantage of this is that by default, any contract that gets written to Stacks is human readable. With Solidity and Ethereum, that doesn't happen by default. The developer or the user has to go through an extra step to decompile that, and that's an external tool not built into Solidity and not built into Ethereum itself. It has to be created. So it's another third-party thing that is just an extra step that you have to do. And so with Clarity, by default, all contracts committed to the chain exactly as they were written, which just helps a ton with making everything more transparent and making it more readable. And then the second thing is that Clarity does not allow reentrancy. So Clarity considers reentrancy an anti-pattern, and it is disallowed at the language level. If you're not familiar, go ahead and look it up, dive deeper into it. But at a high level, reentrancy is where one contract can call into another contract before it's finished executing, and it can start this back and forth pattern to where somebody can perform a second action before the first action has been completed. And this has been the cause of a few hacks and exploits in the past. Again, it's something that has to be in Solidity on Ethereum. It's up to the developer, but Clarity does not allow it at the language level. Another feature of Clarity, another thing that it doesn't allow at the language level, is that overflows and underflows are automatically aborted. And so what this means is that if some function that you have in your smart contract generates a number that is either too big or too small for the language to handle, it will automatically abort. So that's not going to cause any problems for you. It's just going to cut it, and the function execution will end there, and you won't have to worry about that. One of the other cool things that we'll go over in just a minute when we look at the code sample are that custom tokens are built in. And so instead of having to use something like OpenZeppelin where you have to create the actual tokens functionality in the token interface itself from scratch, these tokens are first-class citizens in Clarity. So we'll look at that in just a second, but there are built-in functions in Clarity to define like non-fungible tokens, fungible tokens, and so you can create your own fungible cryptocurrency tokens on Stacks, you can create your own NFTs on Stacks, and those functions are built right into Clarity. One of the other things is that Clarity is decidable, and so from the code itself, you can know with certainty exactly what the program will do. This has a couple advantages. One, it allows us to do something called post conditions, which we're going to go over in just a second. But the other thing you can do is that it's guaranteed that the program execution will end, and you can get an accurate picture of the exact cost that it's going to cost to process that transaction before execution actually happens. So this is pretty theoretical, so I'm not going to get into it now, but another thing to look up is decidable languages and Turing non-complete languages, which is what Clarity is, versus Turing complete languages. Solidity, for example, is a Turing complete language. So go ahead and look at the differences in that because it's really interesting and it's worth a look. But from a high level, the main advantages are that you can know exactly what the program's going to do just by looking at the code, and it's guaranteed that the execution will end, which on something like a blockchain, which is a globalized distributed network, is a really important feature to have. And again, that also allows us to do something called post conditions. So on the Stacks network, what we can do is if we're building a full stack dApp using Stacks, on the client side, when a user is initiating a transaction, we can put into the JavaScript, okay, once this transaction runs, these things should have happened, and if anything else happened, the transaction should be aborted. So what happens when a user will initiate the transaction? Let's say they're going to purchase an NFT, and the NFT costs 10 stacks. There will be a window that pops up in their wallet that says, this transaction will transfer no more than 10 stacks from this contract to this contract, otherwise the transaction will abort. And if you were to try to initiate the transaction and somebody was trying to do something fishy and say double the stacks you were going to transfer, the smart contract function would just automatically abort, and the user would only be required to pay the gas fees to process that transaction. One more thing, the return responses cannot be left unchecked. So in Solidity, it's up to the developer to make sure they are handling any return responses. In Clarity, you cannot write a function without handling the return response, which just helps to make more functional, clean code that is less error prone. Another thing that makes it unique is its composition over inheritance. So rather than contracts inheriting from one another, developers instead define traits, which are then implemented by different smart contracts. So instead of having like a class-based system where a contract will inherit things from one class down to another, you can implement piecemeal traits and then your contract can interface with those, and the main purpose of that is to define standards. So like there's a good example is one for NFTs. There's an NFT trait, and by implementing that trait, you then go into your contract itself and you have to define these certain functions that do certain things, and that is to make sure that there are cohesive standards across public interfaces for different smart contracts. And then finally, went over this a little bit before, but it has access to the Bitcoin chain, which means that we can read the state of the Bitcoin chain and take action based on that. So real quick, I want to go over just a few lines of code to create an NFT in Clarity. This is just going to be super high level, super whirlwind, and then I'll give you some resources at the end. But this is the basic first initial amount of code that you would need to implement an NFT. So Clarity is a Lisp-like language, and so you'll see a lot of parentheses, which is weird at first, especially if, like me, you were used to languages like Solidity and JavaScript. It's definitely structured a lot differently, but once you start using it and it clicks, you realize how kind of clean and beautiful it is. So what we're doing here is we're calling a built-in Clarity function called define non-fungible token, fabulous frogs, and the identifier there is a uint. So just that one line of code created an NFT for us. And then down below, we're implementing another couple of built-in Clarity functions to mint that and give it to the transaction sender, to transfer it and send it from the transaction sender to another principal, which is another word for a contract in Stacks. And then we can also get the owner, and we can burn the NFT. So these functions have built-in security properties so that you can't transfer an NFT that doesn't belong to you. You can't burn an NFT that doesn't exist. You can't mint an NFT that's not unique. So if the ID is already taken. And so these are some built-in security features of Clarity that just make it a little bit easier to write contracts like this. And then what you would do with something like this is you would then implement a trait which would allow you to create the public interface for this contract so that other people could interact with it in a standardized way. So that is the super whirlwind high-level overview of Stacks and Clarity. If any of this jumped out to you, if this was interesting to you, I have this page that I created of resources, stx.is/web3con-resources. So you can go there. You can check out, I've got some getting started tutorials on there. I've got some more information on Stacks and proof of transfer. So go ahead and dive in there, see what's interesting to you. I also have my Twitter link on there. So if at any point at all you have any questions, want to get involved in Stacks, need help, whatever, feel free to reach out to me on Twitter. My DMs are open. So thank you so much for taking the time to watch this. I know this was super quick and probably a little bit confusing, but if you dive into these resources and reach out if you need any help, I'd be happy to help you with that. Again, thank you so much for your time. I hope you enjoyed this, and hopefully I'll see you soon. Thanks.